Hello folks, welcome back. We were discussing the water resource engineering, the chapter called hydrology. In the last some videos we have discussed the forms of precipitation, types of precipitation, rain gauges, the different types of rain gauges, how you are going to calculate the rainfalls in some areas, what are the methods you are going to use it, and some problems are there we will be discussing after this completion of this unit. So now the last part of this unit is the hydrograph and its definitions, the definitions of different abstractions from precipitation, just like in the first video what we have discussed in the hydrology, the evaporation, transpiration, evapotranspiration, interception, depression, storage and the infiltration we will be discussing in this. And next is runoff, estimation of runoff. In estimation we will be understanding what is this runoff coefficient, empirical formula, methods, and we don't have any problems on this empirical formula to estimate this runoff. And the last, the factors affecting this runoff. Next we will be starting with the hydrograph. It is a graphical plot of discharge of rainfall versus time. In the sense, for prescribed time or in stipulated time, how much the rainfall it is been happened. In the sense, this graph you will be seen in some self-recording rain gauges. Next, the discharge is expressed in cumex and time is in hours. Discharge is plotted in y-axis and with versus time on x-axis. It's wrong. In x-axis we will be explaining the time in hours, and in the y we will be discussing the discharge in meter cube per second or cumex. Some example regarding this hydrograph is stream. Initially it is plain, and as rainfall intensity increases, the curve reaches peak and again decreases. In the sense, in this graph you can see as he said initially it is plain. In the sense, here from M to A it is plain. In the sense it is down, still we say it as the plane. It is going linear. Later some point it starts raining heavily from A to B. You can say this some morning time from 6 to 8 it is linear. In the sense it is there is no rain. After some time from 8 o'clock it starts raining heavily. From A to B it reaches very fast. Then again from B to P it is still raining heavily and it reaches the peak, and it starts lowering its intensity. So it starts decreasing from P to C, again C to D, and at last it is D to N. In the sense it is D to N, in the sense it is just drizzling. It is not even the drizzling, it is just what do you say, some parts it might be raining. So this is how it will be. The discharge at B is maximum flood discharge, and area under curve ABCD, the area we will be collecting, and we will be saying it as the volume of total runoff. Just the area we will be collecting, and with this we will be multiplying with the depth, how much it is been collected till that D point. There is one more called a unit hydrograph. In this hydrograph of direct surface runoff resulting from unit catchment area in unit time. Whatever the hydrograph now we have discussed, it is the general one. There is one more type, we say it as the unit hydrograph. In the sense, whatever the surface runoff it is being shown, and whatever the runoff it is been showing for some unit catchment area in some unit time. We will be specifying that time and the catchment area. Within that, whatever the storage or the runoff it is being happened, we will be collecting the data and we will be exposing to the department, and that hydrograph we say it as the unit hydrograph. Next, we will be discussing the abstractions from precipitation. In the sense, whatever the hydrological cycle it is being happened, because of those the terminologies whatever it is mean, I will be explaining in this. The evaporation, it is the type of vaporization that occurs on the surface of a liquid as it changes into gas phase. Similarly, the transpiration, it is the loss of water through plants, or it might be from the roots, trunks, leaves back into atmosphere. Next, evapotranspiration, the process by which water is transferred to atmosphere by evaporation from the soil and other surfaces, and by transpiration from the plants which is nearby that soil or the surface. That we say it as the evapotranspiration. Next is infiltration. It is the process of which water enters the surface strata of the soil and into the ground. Next is interception, a part of precipitation intercepted by trees, objects, etc., which prevents from entering into ground. In the sense, whatever the water it is being precipitated, that being captured by some or the other manner. Just like the tree, if the water it's been precipitated or it's been rained, whatever the rained water it is been flowing like a stream, it is been blocked by these trees, and that water it is been grasped for its preparation of food or any other purposes, or if any structure it is being stopped to percolate into the ground, that we say it as the interception. Next is depression storage. This we say it as the water finding the way into small depressions, filling them into overflow. Just like we are going to construct a barrage or barrier across the river, we say it as a dam, and behind that dam, whatever the water it is being stored, we say it as the depression storage. And next is overflow land. This the water that flows excess after accumulation. The depression storage, whatever the barrage we have been stopped, if that overflow, I mean if the level it's been crosses, then it starts overflowing. That we say it as the overflow line. Next, we will be discussing the runoff, the amount of water which flows over the surface of earth after all losses have taken place. All losses in the sense the percolation, the evaporation, even the infiltration. All this been happened, in the sense it is been happened. After that, whatever the flow it is been showing, just like the streams, nala or the rivers, that we say it as the runoff. The area of land which contributes the runoff into a reservoir is called catchment or basin, and the area we call it as the catchment area. The factors affecting runoff of catchment area is precipitation characteristics, depending upon the form of the precipitation. This catchment area or the runoff, it has been dependent. Shape and the size of the catchment, There are two types, fan shaped catchment and the fern shaped catchment. Fan shaped catchment, it stores less compared to fern shaped catchment. Next, topography, how the land is, the geological characteristics, geological in the sense, or the soil materials characters, the surrounding, if you have any forest areas, some depressions, similarly like geological characteristics and meteorological characteristics, catchment surface and the storage characteristics. So there are different methods of estimating the runoff. One is empirical formula. It is been the method. It has been given some formulas. Those are not related to each other. Those we said as the empirical formulas. Next is by infiltration method. Infiltration in the sense whatever the water, it is being filtered through this soil. After that, whatever the runoff, it has been carried out and it reaches the catchment area. Those methods we will be using it for calculating this runoff. Similarly, the rational method and the unit hydrograph, as I have mentioned in the first slide, in the initial where I have started with the hydrograph. Using that hydrograph too, we can find the runoff estimation too. So this ends the unit hydrology, and thank you.